Yeah, so as I was saying, dude, earlier, the thing is very simple. If you have to do anything for inorganic, it cannot be something which is going to be full. It cannot be aiming to score marks in inorganic. You cannot right now at this stage, because to score marks in inorganic simply means you have to do a lot of work. You have to really spend a lot of time. You have to invest a lot of energy into it. And do you have that kind of energy and time? That is a question you have to ask yourself now. Do you really? Are you willing to invest that much? Sincerely, I'm asking.
Sir, I would, but then like
It is not about you would. Can you afford to invest? That is the question.
no, I don't think it'd be beneficial.
Yes, exactly. So the game is very simple here at this stage. You have to accept the reality of the situation here. This is what we knew, or rather I knew would happen at some point of time. I didn't expect it to happen this early on the stage here, but this was expected. When it comes to inorganic chemistry, you are expected to take the hit at this stage. Because the reality is this, you are simply never going to have the time to prepare it fully. Not right now. Not right now. You will get that time soon. After you have basically cleared your first round of JEE events. And if you have successfully, nicely, cleanly cleared it out, then you get that time straight away. You understand the idea here? It is basically like you keep pushing it till the stage where you have to get it done. But that is going to be borrowed time still. If you do not solve your JEE mains in the first round properly, you will find it very difficult to get time out for that. You'll have to get time out anyway for that at that time, but it is going to be difficult. It will be a board exam holidays mainly. That is going to be your best time, board exam study holidays mainly, because उस time पे पूरा जोश होगा and अच्छा खासा will get like large amount of work done in like very reasonable amount of time frame at that place. Obviously, it will be more complicated, but at this stage here, you have to make sure that you are taking each of these exams seriously for exam practice. See, when it comes to any examination, there are many skills, soft skills which you can basically develop, which are going to be useful for getting better in general at doing better in examinations. So in a sense, when you take, say, let's say I'm talking about your internal exams. In this case here, what can you learn if you're only prepared for the internal exams from the NCERT textbook, which is actually what I'm suggesting. Why am I suggesting that? Because other options are not feasible. Right?
Yes.
It's not that the other options are not going to be correct answers, but are the other options feasible to basically map out right now? No. What is the best option which you can follow over here right now? Get the basic bit done, which you have to anyway do multiple times. Because for it to stay in your brain, you need to do that shit multiple times. Yes or no?
Yeah.
You know that the JEE mains is going to be the first exam which you have to really solve and crack. So any question which is going to be coming from this NCERT textbook, you should take it extremely seriously and try to solve it. If it is not coming from the NCERT, your job is to catch that as a place of information. Try to see if you can game your way into solving it. Sure, you know what I mean by game your way into solving it, yes?
Yes.
Try to see if you can game your way into solving it. But if that doesn't work, do not touch it. And if you feel like, what to say, if you're getting like the instinct that gaming is not going to be working out over here, skip it. The game is ultimately the reality over here is going to be what is the skill you're going to be learning in this exam here.
Yes.
How to score exactly what you deserve. No more, no less. The game is to get no more, no less. That is the game there really. That is a real battle which you have to basically aim for. You have to score whatever you can score. It is going to be a few single digits usually. But you have to get those single digits. Now, why am I suggesting this even though I know it is going to be the outcome which you do not want to hear? Because this is what is necessary. And you know there's going to be no more reshufflings.
Yeah, that's what I also.
You're fucking awesome.
Yeah.
Let's be clear here. So my recommendation here is this. For this week over here, dedicate dedicated amount of time for inorganic. Proper amount of time. Now, how do you give reasonable amount of time, and how do you try to give like slightly better value for your? How do you get slightly better value for your money? Well, very simply put, you read your NCRT and you skim your teacher's class notes. Skim. You do not give it too much time. You know how big that is going to be. It is reasonably big for sure.
It's like 50 pages, but yeah.
50.
Yeah, 50 for 15th group, and then like 100 for 16, 18, 17, 16, 17, 18 all combined.
So he's just taken from there and lifted and put here and given, more or less.
Maybe, yeah, not too sure. Yeah.
Then it is not going to be that much worth it, realistically speaking. Even if you skim, what are you going to be gaining? You only confuse your shit more. 1 hour, I was basically going to be telling you, like, say, 2 hours, how much ever you can skim through it, you skim through it. Something of that sort.
Yeah, it's
So, 50 page ka kya karega, yaar?
Yeah, total is 100 pages for 15 and 16.
100 odd pages.
Yeah.
Just for 15 and 16.
Yeah. The rest is like 60 pages.
एक बार उस बुक को प्रणाम दे दो and then say thank you very much and like move on. Not worth it at this stage. I thought that would be smaller than goddamn the Rama Rao nonsense, but it seems to be similar size only. So anyway, yeah, there is no escape there then. Do the NCRT thoroughly. You'll probably not get any marks at all. Whatever you get, you'll get like few extras here and there. If you get any extra time after NCRT, skim what you can skim in that. And tell me which groups you're going to be having. I'll tell you which are the key areas which you should probably skim through a little bit more carefully.
So should I send the notes itself?
No.
Oh.
I'll be a little bit better. I'll do a bit better than that. Go through the Rama Rao book. In that, there will be a summary. Go through the summary part.
Okay.
At the end of the chapter, there will be a summary usually.
Okay, let me just. Yeah, key points.
Yes, go through that shit.
Oh yeah, there are quite a few.
Go through that shit. That will be like a good concise version which you can like give like reasonable importance to. I thought your teacher's notes will be like a slightly bigger version of that and maybe not too much, but it looks like your teacher's is more or less a shorter version than Rama Rao, but just barely. So anyway, yeah, go through the summary part from that and go through your NCRT class, NCRT textbook.
It's like 12 pages of summary. Yeah.
Sorry?
12 pages of summary.
I know.
Yeah.
That is why I said that the summary is a better way to get it done now. Did you really think I didn't expect the summary would be small? I knew summary was big. It's not that the reality is not going to be that, but it will be a more concise version definitely. And, that's always better now at this stage right now. That's basically what you require. 12 pages you can do in like 2 hours reasonably carefully, reasonably seriously. So try to find like a couple of hours out and do that also along with this. But first thing is going to be your NCRT. If that is going to take you full time, that takes you full time.
Yeah.
Fair?
Yes, sir.
Now, that is what you're going to be doing for for your inorganic here. Organic is going to be your focus mainly though, because you're going to have to basically keep in touch with organic properly, because this is the time when all your hard work starts coming together. Around this time in the next chapter, basically, aldehydes, ketones, because if you have done your homework till now properly, almost everything will get covered up by aldehydes, ketones, and like large chunk of reactions will be happening now in alcohols, phenols, ethers. So tell me, let's start off with the organic part now. What were the reactions which you were properly comfortable with in this particular week's school lessons, and which reactions did you find?
One last thing, for face test, what do I do? Same.
Hmm.
Face test as well, same thing.
Face test?
Face test as well, NCRT only. NCRT
Yeah,
just 2 points. Okay. That's also.
sorry. The logic stands for both the middle face test and the face test also.
Sir, it's only like 60 pages though in the notes. Total, both combined.
Sorry?
In my teacher's notes, both combined are 60 pages. 17,
60.
18. Yeah, 60. Still.
See, if you want to work on that, go ahead, work on that. But the reality is, how much time can you devote to that? So you decide. I would say realistically, time-wise, you can maximum give 1.5 to 2 hours to that. Sincerely speaking. So उस time frame में तुम्हें जो भी हो सकता है कर लो. If you feel your teacher's notes can be completed within a time frame of say 4 hours or so, or 5 hours, if you can knock out like say 4 to 5 hours, then you can always get it done. But remember, you have to basically make sure that your organic is also coming along at a reasonable clip. So 4 to 5 hours is not going to be that easy to find, sincerely. Because 60 pages है तो तुम्हें 4 घंटा तो लगेगा ना, या 2 hours में खत्म हो जाएगा.
Yeah.
You'll finish in 2 hours.
No, I won't. No.
Will you be able to see? The idea here is if you're able to do we don't know what strategy will work right now, sincerely.
Depending on weekend test, we can maybe see something.
We'll try to at least use a shotgun method and shoot everywhere and see if something hits, rather than like focus it and like only in the first half, second half. That might not be particularly more meaningful. This might work out better. After all, this is a full exam where they are using these topics here.
Yeah.
Okay, so let's start off. So tell me the reactions which you have been doing so far in your weeks in this particular week here, alcohols lab, and any interesting reactions where you have had like doubts.
Like the first few were just like revision of previous ones. And sir, we did acidification like last time you asked it.
You did acidification reaction?
Yeah, you asked last time whether we did.
I think I mentioned acidification to you last time.
Yeah, and you said we'll continue on that if once you do. Yeah.
This is acidification.
Yeah.
So, did you do the acidification mechanism fully?
Same mechanism. But then we didn't really focus on. My bad. Yeah. Everything we did, same thing. Yeah. Yes, sir. Rate of acidification and all. Yeah.
You have done the standard mechanism only. You would not have done anything funnier. So you have done the exact same thing only.
Yes, sir. Basically, the thing attacking the ketone and then the carbon. Sorry, and then that thing leaves. Yeah, same thing. An emphasis on where the oxygen will go. Yeah.
That emphasis is unfortunately necessary because you'll be finding questions quite often coming in that direction. Basically, especially good internal exams and all, the way they play with students is using that. And JEE Advanced did that once in a very good paper while back, around like 10 years plus back. So after that, it has become, what to say, style to basically play with this particular oxygen in internal papers.
Hmm.
Sometimes it gets even more interesting because this is not going to be, what to say, what is given over here is for most common or standard mechanism, correct?
Yeah.
So that means there is some weird shit also which can happen. So, what were the steps involved in the mechanism which you learned? First of all, let's not go to this. Give me other. What else did you do this week? The esterification is one.
Esterification, that's one, and then
Mhm.
reaction with concentrated HNO3, and then acid halides, acid anhydride.
HNO3, acid halides.
A reaction with concentrated HNO3, reaction.
HNO3 is direct oxidation. That's all, na?
Yeah, the OH in the yeah, that
Mhm.
one. Alkyl nitrate, and then acid halides, acid anhydrides, and then
So, okay, so esterification. And you've also done RCOCl
RCOCl.
and anhydrides.
Yes,
Okay.
and then reaction with benzene sulfonyl fluoride.
Mm.
And then
You
that
did
this was
tosylation
all
also?
properties due to the sir, what?
Did you do tosylation also?
No, sir. I mean, no, we didn't do that.
Okay.
He gave the reaction CF3 S double bond O Cl plus C2H5OH. I think that's tosylation, maybe.
That is not tosylation, but that is
Sir,
something similar to
try.
tosylation. Yes,
Yeah, that's TF. Okay,
that's similar to tosylation, but that is not tosylation.
okay.
Chalo, okay, all right. Huh?
So this is all the properties due to OH bond cleavage, and then
OH bond cleavage. Okay.
yeah, this was for OH bond cleavage, and then CO bond cleavage. Coming to that, reaction with HX, reaction with PCl3, PCl5, SOCl2, like uh, fluorinating agents, basically.
Mm,
Reaction with NH3,
mm,
and then next category, elimination reactions.
mm.
In elimination reactions, we did dehydration.
Which one?
Dehydration.
Mm,
Dehydration with like Al2O3 and normal dehydration as well.
mm, 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 mm,
And then fourth category, oxidation reactions.
mm,
Oxidation with K2Cr2O7 plus H2SO4.
mm, 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 mm,
Catalytic dehydrogenation.
mm, mm, mm.
And then other oxidizing agents like PCC, PDC. Like he gave like a Jones
All
reagent.
standard ones.
Yeah, he gave like 7 of them, and then he gave one which is applicable, MnO2 and all like that.
Mm.
Yeah, and then once that's done,
Suresh,
iodoform reaction.
give me a second. Give me the list which you have discussed already.
Sir, PCC, pyridinium chlorochemate. Oh, sorry, that K2Cr2O7, and then catalytic dehydrogenation.
Copper,
Copper Ag, yeah.
huh?
Yeah, yes, sir. Copper Ag, yes.
Mm. At
And
570
then
people.
300 degrees. Celsius, oh, sorry, Celsius, 360 Celsius. No, no, correct,
It's
correct.
same thing basically. Huh?
Yeah,
Okay.
yeah.
Okay,
And
next.
then
What
PCC,
else? PCC, PDC.
PDC, CrO3 plus 2 pyridine
Hmm.
in C2C in CH2Cl2. And then only, no, sir. Yeah, fine, what was thinking. And then DMSO plus oxalyl chloride.
DMSO plus.
Oxalyl chloride. Is that
Okay,
possible?
TMS oxidation is sufficient. Huh?
Yeah. And
Hmm.
then Jones reagent,
Which version?
H2 CrO3 plus H2SO4 plus acetone, or H2CrO4 plus acetone.
Okay, huh?
And then MnO2.
MnO2.
Yeah, that's it, sir.
Silver carbonate.
No, sir. We'll do that.
And okay, all right. Now, in this year, let's see, which one should you pay? Okay, next, what else have you done? Let's finish off what else you have done. Let me put down the list fully and then I'll start discussing.
Then he gave a few specifics about Jones reagent and MnO2.
CrO3 plus which medium? No.
He just gave Jones reagent, like CH2Cl2. He gave a solvent.
You did this?
What? 1 second. No,
Glacial
sir.
acetic acid.
No, sir.
No. Okay, all right. Chalo then. No, then. Okay, all right.
And then iodoform reactions.
Now we come to something really big and really spectacular. Okay.
Yeah, he gave 3 stars next to it.
Okay.
And
Next,
then Lucas test.
Lucas test is also something fairly useful and important.
RBC test, Victor Mayer test.
Victor Mayer test. Okay.
Then CAN test, Ceric ammonium nitrate.
Cetic ammonium nitrate. Yeah.
He told we're gonna do POC like side by side.
That is the way it is.
Okay.
That is the way it has to be done.
Yes, sir. And then this was where alcohols ended, and we started preparation of, like, if you like in NCRT, it seems preparation of methyl alcohol was given specifically. So he gave that, and then
Importance in NCRT using the enzyme and enzyme catalysis and all.
the
Fermentation basically.
no, not fermentation. He gave that before already.
But that is already given already. Okay.
And then we discussed ethylene glycol and its reactions.
Why ethylene glycol?
Why? I'm not sure. Might have been
Okay.
given in NCRT.
No, it is not an NCRT. Next up,
And then properties of that, reactions of that, and
reactions of.
this ethylene glycol. Then he emphasized on when HI is reactive. Then the
I think we discussed that already last time.
Yeah.
Some time back we did,
Yeah, a while back we did that. Yeah.
That was for glycerol. I think we discussed that, right?
Yeah, the eyes are unstable next to each other.
So that is going to be for applicable for ethylene glycol also, obviously.
Yes, sir.
The
Yeah.
same thing basically applies there also. Okay. All right. And then what else?
And then glycerol we discussed.
Glycerol also same kind of crap.
Yeah, exactly.
Okay. What else?
That's it.
Glycerol saponification he did.
What? The glycerol what?
Saponification reaction.
Sulfon? No, sir.
Saponification. Soap.
Oh, no.
No. Okay.
So
All right. Now, what else did you guys cover in this week?
that's it, sir.
That's it. Okay. All right. Cool. So let me quickly get to each of these parts here and talk about things a little bit here. Esterification is a fairly, what to say, high level importance reaction. All right. This is something which is very important from the point of view of pretty much exactly what we discussed. Now, other than that, what is important in that particular reaction there is knowing and understanding how the reaction's mechanism is going to be actually dictating what is going to be the better substance for the reaction to happen. For instance, if I'm going to be looking at esterification here, let me put down the reaction now. So let's say I'm having RCOOH plus R-OH. Now, in this particular reaction here, what type of R is going to be resulting in a faster reaction?
Less sterically hindered.
So basically the idea here is for a faster reaction, you're basically clearly saying this particular molecule here R should be less sterically hindered. Right?
Yeah.
Why?
Because when the RDS, this thing comes, ROH is attacking.
So you're going to be having the rate determining step, basically involving the attack of this fellow here on this location.
That is already pretty big. I mean, yeah.
Right. So if you're going to be having attack happening on this location here, you're going to be obviously having steric hindrance at this location, definitely playing a key role over here. So you're going to be having, for a faster reaction, less sterically hindered RCOH is better. Okay. All right. That is one way of looking at it. Next up, what else? What else will be necessary for a faster reaction? So let's look at the reaction mechanism a little bit more closely now by looking at the products here. Can you list out the products for me in the reaction, dude?
You get a RC double bond dose. Ester you get O R dash plus H2.
Now, in this particular reaction here, we are going to be using catalyst. Yes.
Yes, yeah. H2SO.
What is the catalyst?
H2SO. Yeah.
Why?
It gives it starts the reaction by attacking the keto, the oxygen, double bond oxygen.
What do you mean it starts the reaction?
I mean, like, one second. Let me think.
I have a question here for you. I have a mixture, okay, which contains different bases, 3 different bases or 4 different bases. I am adding an acid to this. What will the acid react with?
Strongest base.
Right?
Yeah.
Not that it will not react with the others, it will react, but mathematically speaking, it is always better to go as acid reacted with the strongest base. Right. Now, if I have a bunch of bases which are all weak, none of them are really strong, all of them are shit, none of them want to accept the acid. Acid is also not a domineering fellow. Then what will happen? Then you'll get like a mixture of shit happening.
Exactly. Yeah.
Right? You'll end up having all of them like little bit here, little bit there. That type of shit will basically end up happening there. That's basically what happens right now over here. In this case here, when you're going to be adding H plus, H plus is going to be not reacting specifically with this location. You're saying it will go attack here, correct?
Yeah.
How on earth will it go attack over there? When there is this, when there is this, which are far better.
Yeah, that was also one of my doubts. Yeah.
You think for a second and you tell me. Right? So the reality is H plus is going to be definitely making the reaction faster. Yes, but not the way you think exactly. Yes, it is going to be helping, what to say, the idea here is it will help increase the delta plus on this carbon. The easiest way to talk about how H plus helps is to basically describe it like this. Instead of saying it will go attack this oxygen here, yes, it will go do that here, here, and here. It will attack all of those locations, not just over here. It will attack here definitely. It will attack here also, and it will attack here, here, and here. And that basically is going to be, at the end of the day, increasing the delta plus on this carbon.
Yeah.
So the delta plus on the carbon increasing is going to become the key aspect over here. Don't try to sell it as it attacks over here. That is going to be a problem if you look at it. There are going to be more questions. Yes, can't tell me.
Why are you not considering the C double bond OH, that OH?
This OH,
Yeah,
it certainly can attack here also.
that's what.
But the problem here is this oxygen is already in resonance.
That's one point. Yeah, that's true.
So it already has a delta plus.
Yes, sir.
That means this delta plus and this plus flow over here, they'll repel each other.
Repel. Yes, sir.
Now, let's come back to the next point here. So, in this particular case here, if the R group is going to be smaller, reaction will happen faster. If you're going to be having H plus, it will somehow or the other catalyze the reaction slightly. Okay. Now, what else? What else? How about the alcohol? What should this guy be?
Less tightly hindered, that as well.
Why should that guy be less sterically hindered as well?
Because that is also attacking.
So R dash OH. R dash should be less sterically hindered as well. So you'll end up having, if this is less sterically hindered, reaction will again happen faster. Okay.
Yes,
all right. Now, you will always have what to say. Okay, this is perfectly acceptable. You gave the correct answers till now properly.
I think.
Yes, tell me.
Sir, the would the what's it called? Type of alkyl group also matter, like secondary, tertiary, primary.
This R and the R dash?
Yeah.
Obviously.
I mean, would that be taken care of in like the stately ended point, or like would we have
this
to?
Gets taken care of here itself to an extent, in this point itself to an extent, no doubt about that. But at the same time, you're also going to be having, what to say, the doubt which you're having is what happens when you get bulkier and bulkier.
Yeah.
Now, that is basically the doubt which you should be moving towards. That is going to be something which is going to be your boundary condition. So, there are two ways of boundary conditioning here, correct? One is going to be boundary condition on the R, another is going to be boundary condition on the R dash. Both are feasible boundary conditions. So let's say I'm going to be having the carboxylic acid like this. What happens in this particular case?
Here,
if I have alcohol like this,
yeah,
what happens in this particular case? These are boundary conditions.
Yes.
So let's now look at the boundary conditions here too, just to what to say, don't think too hard over here, because in this case here, I'm going to be very honest with you. I gave you a bunch of conditionalities, or rather I gave you the standard mechanism products. They will not apply now.
Okay.
They are not going to be applicable. So don't think about applying them. It will not be meaningful over here. Now, first of all, what is it that is happening in the reaction, in the esterification reaction? Broadly, what is happening? You're having the alcohol attacking as a nucleophile.
Nucleophile, exactly.
And you're having a nucleophilic addition reaction happening here in the beginning, followed by a nucleophilic elimination.
Yeah.
Of water. Right. So effectively, you're going to be having a nucleophilic addition and a nucleophilic elimination happening in the reaction. So now the game is to perform the nucleophilic addition and the nucleophilic elimination in the most efficient manner. So in the boundary condition scenario here, we are not going to be discussing the conditionalities now. You think about it and then you come back to me about the boundary condition answer. But we will discuss what other conditions favor this reaction. What else is going to be favorable? It's an equilibrium reaction. Why is it equilibrium? Because there is only acid-base reactions, or there is going to be nucleophilic addition or nucleophilic elimination happening in the entire mechanism. All steps are reversible. So, what is the other critical thing which you should make sure here in the reaction? Remove the water constantly.
Exactly. Yeah.
Or make sure that there is as little water as possible from the beginning. So we'll be using concentrated H+.
That's
That's
right.
the
Okay.
idea here.
Hmm.
Dilute, if you add, it will basically push it in the backward direction.
Yeah. Okay.
You understand the idea here?
Yes, sir. Yeah. Hmm.
Now, boundary condition, have you thought a little bit? What do you want? What do you have as a point of view? How do you think the mechanism should adjust itself? Products will be similar. Products will not be adjusting.
Then maybe
Mechanism will adjust itself slightly internally.
substitution would happen
When
instead
or
of
where is
adjusting.
going to be the change? Think of it like this. If I'm giving you that same, I gave you the esterification reaction in like one shot, na?
Yeah. Yeah.
Yeah. If you have to write it like that, in this fashion here, how would it look? Which oxygen will be where?
Oh, like that you're asking. Okay.
Hmm.
If you
Not now.
would,
Not now. Not now. Play with it afterward. Okay. That is going to be the game here. Play with that afterward. I'm not going to be giving you the answer for that, but you can find that out for sure if you sit and try it like this. Now, so that is your esterification. I want to just discuss these things over here for esterification. That is taken out. Now, RCOCl and anhydrides, I'm sure you have discussed that. The reaction with RCOCl is going to be going faster. Yes.
yes.
And anhydrides is slightly slower. Both of them are
Okay.
going to be similar mechanisms to esterification. They are both going to be nucleophilic addition
Addition
elimination
then substitution.
mechanisms.
Yes, elimination. My bad. Yeah.
Nucleophilic addition followed by nucleophilic elimination.
Sir, you were saying something about the rate of reaction. What is it?
The rate of the reaction or the speed of the reaction is going to be faster for the acid halide compared to the acid anhydride. Acid halide will be faster than the acid anhydride.
I'll read that one.
Okay.
Like for the keeping the constant, the R group and R dash group constant. Or like how do you comparing it? Okay.
Keep it as constant.
Okay. So is it because Cl would be a better leaving group? That is the
Yes.
okay.
So the next thing which I wanted to touch upon was what is called as tosylation. So tosylation is going to be involving this fellow here, which is called as para-toluene sulfonic acid.
Sir, can I drink water and come back? Just a minute.
Yeah, please.
Yeah.
Now, when it comes to this tosylation here, tosylation is something which I wanted to just touch upon a little bit over here. It involves a fairly interesting compound called para-toluene sulfonic acid. This one which I have over here. Now, what is going to be the what to say advantage, or what is the purpose of this particular tosylation here? What is the use of it? It's like this. So if I'm going to be having the ROH over here, present as it is. All right. Now, usually when you're going to be having the OH group over here, the OH group is not a good leaving group, right? Not a good leaving group. Why?
OH minus is not really.
OH minus is very unstable.
Yeah.
It is absolutely not a good leaving group. So when you want to basically kick the oxygen out, how do you have to basically do it? You convert the ROH into an ROH2 plus. Right, usually. And then you kick this out as a water molecule. which is not a good leaving group, but decent leaving group. It is not a good leaving group, but it is an acceptably decent leaving group. But you can make this into an even better leaving group by doing this. So if I take the ROH and I react it with the para-toluene sulfonic acid, so when I react it with para-toluene sulfonic acid, what happens is we end up having this guy gets formed. Okay, so
Yeah.
this compound here is going to be something where this entire part is called as an OTS group, which is generally an abbreviation for tosyl.
Yeah.
Okay. Now, when it comes to this tosyl over here, what is going to be the speciality of this? What is going to be the advantage of this? So if I have ROTS present now, in this here, this OTS minus, this TSO minus will basically be something where you will have this as the species now. O minus here. This O minus will have resonance.
Resonance, exactly. Two different resonance. Yeah.
Right? So this is going to be much more stable.
Yeah.
So this becomes a good leaving group.
So then what's the use of the phenyl, the benzene?
Yes.
What's the use of the benzene there? It's like,
It's just there.
what? Okay. Okay.
As in, I do not understand your question. You're asking why do we need to have a benzene ring? Huh?
Yeah, I mean, like, if the resonance is only between the, if why can't we just have
No,
a
there will be resonance, of course, outside also. That is not going to be helpful here. Right? It is not helpful, but there are two oxygens anyway, two double bonds are there, so no problem. This got enough resonance to stabilize it. So the idea here is this is going to be reasonably stable. You have something to say still.
No, even if the benzene wasn't there, suppose it is CH3S double
That will
bond.
also work.
Okay.
So this is going to be a good leaving group. So what is the advantage of making it into a good leaving group? The advantage is very simply this. ROTS can now do SN2 reactions. You understand what I mean by SN2 reactions? Whatever you studied in alkyl halides, bulk of them will now become applicable for this guy.
Okay, but okay, yeah, got it.
You understand the idea here?
Yes.
So you're going to be having ROTS is now very much capable of doing SN2 reactions. And sometimes when you want to basically remove, what to say, or to break the RO bond, tosylation is a good trick. Because when you tosylate, it becomes easier to kick it out using SN2. So to break the RO bond, the steps will be tosylate first, then do SN2.
Okay.
You understand the idea here?
Yes, sir. Okay, that's nice.
Okay.
Yes, sir. Yeah.
Now this is docylation, so this part is done now. Okay. Now among this bunch here of oxidizing agents, K2Cr2O7 is of course important. Copper at 573 Kelvin is important. Remaining, all of them put together, you can say that what to say. You need like to like just know about all of this. No need to know beyond that. Just know a little bit about the fact that all of these will do oxidation of alcohol to aldehyde or ketone properly.
Yeah,
Correspond.
yeah. At the
And
end, it
you're
will
going
be
to be
stable.
having.
Sir, what?
You said something just now?
Nothing. Sir, no.
Okay. And in this here, the MnO2 and the Ag2CO3 here. What is special about the MnO2 here?
It is selectively oxidized.
What
Benzylic and
selectively?
allylic.
Which one does it attack?
Benzylic allylic.
Correct. So the Ag2CO3 is also going to be doing the same thing. All right.
We'll write that
Both of
down.
these two guys are going to be selectively targeting only your benzylic and allylic locations specifically. All right.
Others
So,
also do it, but not selectively.
yes.
Others also attack benzylic and
Others
allylic.
also attack them, but they will not selectively target. These guys are selectively going to be targeting mainly and only attacking them.
Okay, sir. Yeah.
Okay. Now, other than that, yeah, remaining things seem okay. Now,
So,
yes.
he also gave like a few points based on Jones reagent. If alkenyl or alkynyl group or phenyl group are there in the alcohol, then primary alcohol gets reduced to only aldehyde, or else it will get reduced to carboxylic acid.
Reduce the oxidase.
So oxidized, my bad, oxidized. Oxidized. Yeah,
Yeah,
that's
go on.
it.
No, it's fine. Correct them.
Okay.
The idea here is, yeah, I suppose I'll mention that. I'll just quickly describe that part here. So when it comes to oxidation here, one of the key things which you should remember here is this. In the stages of oxidation, what happens is you're going to be having ROH, alcohol, becomes the aldehyde. Or in some cases, it can also become the ketone, which then ends up becoming the carboxylic acid, which then usually ends up becoming carbon dioxide.
Okay.
These are the different stages of oxidation. Okay.
Yes.
Now, when it comes to each stage over here, you're going to be having some stages are going to be tougher than the previous, some stages are easier than the previous. So in this case here, alcohol to aldehyde or ketone is a difficult stage.
Okay.
But aldehyde to carboxylic acid is an easy stage. Similarly, ketone to a carboxylic acid is a very difficult stage.
Oh, okay.
And the last one, RCOH to carbon dioxide, conditional case or condition specific case. So it happens when certain conditions are satisfied. It does not happen if conditions are not satisfied.
Okay.
Okay. So that is basically the idea over here. So this is basically how your oxidation goes for different stages. Problem is going to be this. When you're going to be having alcohol in this pathway here, have a look at the black mark pathway here.
Yeah.
You're going to be having a difficult stage followed up by an easy stage.
Yeah.
So what happens in that particular case there is when you're having a difficult step followed up by an easy step, both steps will happen together.
Okay.
You understand the idea there? If the
Makes sense.
oxidizing agent is going to be something which is like reasonably even decent, what will happen is both steps will happen together simultaneously. So when both happen together, what's going to be happening is you're going to be not capable of stopping the reaction at the aldehyde stage. It will go directly to the carboxylic acid stage, which is basically what you're talking about here, right? That's what you're saying, no?
Yeah, exactly. Yeah.
And if it is going to be giving you the ketone, though, it will stop. No problems. No issues with ketone. The problem is going to be only when it comes to the aldehyde there, because the aldehyde can easily undergo oxidation to become carboxylic acid.
Okay.
You understand the idea so far now?
Yes, sir.
Okay. Any other doubts in oxidation so far?
One second. Just a second.
Any other doubts regarding oxidation?
Just a minute, sir. One second.
Yeah.
So this is not exactly what he wrote, right? Like he told that if there's an alkenyl or alkynyl or phenyl group, then primary alcohol gets oxidized to aldehyde. How are these two same?
Or what?
So if alkenyl or
Is
alkynyl
what?
or sir
With?
Jones reagent.
No. Jones reagent is basically saying that Jones reagent, you will have aldehyde happening there. He's saying, what is the product given there? You give me the full thing. Now tell me the point now.
So he said if alkenyl or alkynyl or phenyl groups are there in the alcohol, the primary alcohols get oxidized to aldehyde only.
And it stops there is what he's saying.
Yeah, he said only aldehyde. So I'm guessing it stops there. Oh yeah. And then the next point he gives it said if these are not there, then it continues to form carboxylic acid.
Yeah. So basically he's saying that when you're going to be having alkenyl or alkynyl, you're going to be having some resonance happening over there, which is going to be stopping the oxidation at that stage.
Okay, resonance is the key. Okay. Yeah, no, okay.
So the resonance is going to be involved with the aldehyde over there, which is going to be capable of, for whatever reason, stopping the oxidation reaction at that stage there.
So basically, second step will also be hard. So don't bind into the same step.
Yes, the second step becomes more tougher there.
Okay.
Basically, instead of having it as a very easy stage, it is becoming a slightly more difficult stage. So if it becomes a slightly more difficult stage,
Both
automatically stops out there.
Yeah.
Next, let's move on from oxidation now.
Iodoform.
Before we go to those guys over here, let's go for Lucas test.
Okay.
What did you understand in Lucas test?
It's like the turbidity forming. Just like whether the thing is soluble. Like how do I exactly
Summarize Lucas test, Ra.
So basically we're reacting an alcohol with this HCl and ZnCl2 anhydrous. So if the reaction does take place, then alkyl halide is formed. And the alkyl halide is not soluble in water. So like if the thing becomes turbid, that means RCl is there. That means the reaction happened. That means the alcohol is there. So its identification takes for alcohol. And then for 3 degree, 2 degree, 1 degree, it's like different. Like the rate is different, rate of reaction. So you can compare along those lines as well.
Okay. So the test over here is that you're going to be getting what exactly?
Alkyl chloride.
alkyl halide, which comes out as
Turbid precipitate.
white precipitate.
Yeah.
So let's first quickly talk about what is going to be the mechanism involved here, and then talk about the next bit there. So when it comes to the reaction mechanism here, the reaction mechanism is going to be deciding what is going to be the products and the test results. So let's first look at the test results, then we'll understand the mechanism from there. So the test here is very simple. ROH plus concentrated HCl in the presence of anhydrous ZnCl2 is going to be producing RCl. Right? So the RCl comes out as a white precipitate. Correct? So this white precipitate is going to be, observation of this white precipitate is the test over there basically. Now let me put down the results over here. So 3-degree ROH or benzyl ROH. These basically give immediate white precipitate or immediate turbidity. Okay. Next up, secondary alcohol. What is the observation?
Slower formation of turbidity.
Any other observation over there? Anything else to add there?
No.
We need to heat it also.
Oh,
all right.
Only for 1 degree or 2. Okay.
So for secondary alcohol over here, you will have to heat this fellow over here to basically have a chance of getting the thing here. 1 degree ROH. What's the observation?
Like after a long time, and then you have to heat a lot. No reaction.
Yeah.
So
that is a general accepted thing. Don't take it as after a long time. Take it as no reaction, please.
Okay.
Okay. And you're going to be having methanol, obviously, will be 0 degrees, only one fellow there. Methanol only. Methanol also is no reaction. Now, what is the idea over here? How is this reaction supposed to be going here? If it is going to be giving you this kind of scenario here, quite clearly, mechanism has to be carbocation mechanism.
Yeah, exactly.
So, if it is a carbocation mechanism, what is going to be happening here in this particular case here? You're going to be having rearrangements being definitely possible. Right? Because it's going to be involving carbocations. And in this particular case here, if you're going to be having, what to say, carbocation here, rearrangement is possible. Heating is also because of carbocation effectively. The heating is also basically because the carbocation is going to be requiring some activation energy to form. The heat will basically supply that energy to basically get the carbocation in good shape. That is going to be one of the things there. Now, let's talk about a couple of other points over here. First of all, why do I need anhydrous ZnCl2? What is the other product, by the way, other than the RCl?
Water.
So, what is the role of anhydrous ZnCl2? What is the role of concentrated HCl? What's the idea here?
1 minute. Sir, if it was hydrated ZnCl2, then there's a chance of that reacting rate, the H2O. But wait. So the concentrated HCl is for the H plus generation.
Good.
Yeah. And then you want high concentration of that. So that
ZnCl2 is also for that only actually.
oh
Because when you want H plus generated over there, you need something else to accept the Cl minus, na?
oh yeah, correct. Yes.
There is no water now in this particular case here. Somehow or the other, we have to stabilize the Cl minus. The Cl minus normally will be stable because water will be present.
Okay. Yeah.
There is no water here. So you're going to be having to require something in the medium to stabilize your Cl minus. So what
Yes,
happens
sir.
over there is you'll end up having Cl minus combines with your ZnCl2 to basically exist as ZnCl4 times 2 minus. So zinc ends up forming a chlorido complex over here like this, ZnCl4 times 2 minus, which stabilizes the Cl minus. That's the role of your zinc in this particular case.
Huh.
Now, in this particular reaction here, you're going to be having fairly straightforward reaction mechanism. You'll have H plus, you'll get what to say water molecule eliminated out, and your water molecule can also form zinc wala complex. It can form ZnH2O 4 times 2 plus. Right, so water can also form this complex. So you'll have both complexes technically available. Doesn't matter which one is what to say happening there, but the reality is you'll end up having reaction mechanism being something like this. Tertiary alcohol and benzyl alcohols will give immediate white precipitate, immediate turbidity, and they will give it at room temperature itself.
Okay. So this ZnCl2 aqueous also applicable. This
ZnCl2.
aqueous. Sir, not aqueous. I mean, in the presence of water. This entire reaction in the presence of water.
This water is also going to get trapped away by the ZnCl2 in this fashion.
Yes, sir. Yeah, I got that. But then, like, if we didn't have you said the Cl minus basically should be stabilized, right?
Cl minus is getting stabilized by the ZnCl2. Yes.
Yeah, but like if ZnCl2 was not there,
That's
and
why
we are
using anhydrous ra. In the reaction, we use anhydrous ZnCl2. No, have a look. If I had it hydrated, the Zn will basically go off like this. With water, you want to avoid that happening. So we make sure we use anhydrous.
Okay. My bad. Okay.
Okay, yeah.
Yes,
And
sir.
in this particular case here, you're going to be purposely using anhydrous so that you're going to be having the ZnCl2 properly existing with and taking off the chloride ions. Okay, now coming back to the Lucas test over here. Where were mechanism there? You're going to be having what to say H plus attack happening first. You'll get ROH2 plus 1 formed over there. The water molecule gets kicked out, carbocation is formed. That is when the rearrangement can happen. Aman?
Yes, sir. Yeah.
So when your carbocation is formed, rearrangement is very much possible here.
Yeah.
All right. And when you're going to be doing it for the secondary alcohol, you use a water bath usually, or sometimes an oil bath as well. If you want to get it in the primary alcohol, I'll give you the temperature ranges which are required over here. For secondary alcohol, the temperature range required is going to be like 80 degrees to 90 degrees.
Okay.
Celsius. All right. So this is going to be the minimum temperature required. So this is going to be possible by water bath. So if we are using a water bath, it will definitely give the product here. Now, 1 degree alcohol, why did I say no reaction? The main reason is because 1 degree alcohol, Kelly, if you want the reaction to happen, you need the carbocation formed.
Yeah.
Primary carbocation is generally formed above 110 degrees Celsius. All right. So, with water bath, no reaction.
Okay.
But if you use an oil bath, you'll have reaction. You understand what is happening there?
Okay.
Oil bath, na, if you end up somehow or the other pushing the temperature above the 110 degrees Celsius, then you will have a chance of 1 degree alcohol also giving you white precipitate. It will take a long time, but there is a possibility of it happening. You
So does
understand
this
the
have
idea?
anything
Hmm?
like oil and water, like anything to do with the specific heat, like something like that?
No, it has to do with the boiling goddamn points. Think for a second.
Oh yeah. Sorry. Correct. My bad. Yeah.
Good bugger. Sometimes you have to think basic.
Okay. My bad.
Thinking, overthinking shit, specific heat, it seems. Uh, this is
Okay.
boiling point. Water
Yeah.
boils
It's
at 100 degrees Celsius. So
yeah.
water cannot be used for anything around 95 plus. It is not going to be feasible. So if you want to go above 100 degrees Celsius, you simply cannot use a water bath.
Yeah.
You use an oil bath, or you use an oil bath in that particular case. So when you
Yes.
use an oil bath, yes, it works. To what is after a very long period of time, proper heating. Water bath, no chance.
Okay.
Now, this is going to be your Lucas test. Okay. Now, what else? Lucas is over. Okay. Victor Mayer's test. I think these ceric ammonium nitrate and these guys are okay. Those are not a problem. Victor Mayer's test. Let's talk a little bit about Victor Mayer's test. What did you understand by that?
So I mean, uh, first like the like it was like a series of reaction. Like, first it was that with px3 and then P
Okay.
pi3. Okay, wait. Pa3 and then AgNO2 and then
So
NO.
let's talk about the series of steps. So what are the steps done first? We hit
First
this with px3 first,
pi3. Yeah.
pi3. So you get ri. Then what do you do?
Then AgNO2.
AgNO2.
Sir, why exactly are you using AgNO2? I mean, next I know like tautomerism will occur, like or hmm,
You tell me. After this step, we will come back to AgNO2 in a bit. Tell me after this step first what happens next.
so the example we took was RCH2OH. So like tauto. Oh, sorry, no. Here and then
1 second. After RNO2, what happens?
that thing 1 second. HNO3. No. H2. No. That's it. Yeah, HNO2. My bad.
What is that?
HON double bond O. That. Yeah, exactly.
Oh, okay, all right. Now let's start discussing each part here. I'm assuming this part is okay.
Yeah.
AI3.
Yes, sir.
Now AgNO2. What is happening here?
Acid base. No. Not acid base. My bad. Sorry.
What is
Um,
the reason why the reaction happens?
Flexibility. Forward reaction probably fail.
This is a precipitate. AgI is a proper precipitate.
Yeah.
Okay. So in this case here, silver iodide is very stable precipitate. Yellow color.
Okay.
And it is highly insoluble also. Okay. So this precipitate is the reason why you end up using this reaction here, AgNO2 there. Okay. And you want the nitro cell, you want the nitro basically to go there, so you do this. Easiest option to get it done. Now, let's talk about what is going to be happening in the RNO2 stage there and what happens afterward. So let's say I'm going to be having a primary alcohol. Okay, let's say I'm taking primary alcohol. This guy has a primary alcohol here. Ethanol is the fellow there. Ethanol, if I'm doing the reaction, the Victor Meyer's series of sequence of reactions over there, I will be finally at this stage here.
CH3, CH2, NO2.
I'll have like this. So this is my species right now, correct?
Yeah.
NO2. Now, if I'm going to be doing NaNO2 HCl here, this will generate what? We talked about this already. This generates HNO2.
Yes, sir.
In turn, generates what?
NO plus.
NO plus.
NO plus, yeah.
So this is called as your nitrosonium ion. So this nitrosonium ion is going to be the guy who is going to be an electrophile right now. So this electrophile will go displace some other electrophile, right? Electrophilic substitution karega.
Yes, sir. Yeah.
Right? What substitution can it do? In this molecule, which guy can be substituted by an electrophile? Hydrogen. This is the fellow which can do electrophilic substitution. Yes or no? Nothing else is possible to be substituted here?
Yes, sir. Yeah.
So we have that guy getting substituted. So we get carbon, carbon. This hydrogen will remain intact. I will have an NO here and I will have an NO2 here. Okay. So this compound is called nitrolic acid. Now, the idea here is that this hydrogen is an acidic hydrogen. Why is that hydrogen going to be an acidic hydrogen? Well, very simply put, if you have a C minus here, then there is an NO ready to stabilize it, and there's an NO2 also ready to stabilize it.
Yes. Yeah.
So you can have resonance stabilization like this. So this is an acidic hydrogen here. This is called as nitrolic acid. That's the game here. Next up, if you're going to be doing for a secondary, what will you be getting there? If you have a secondary alcohol, you start off with this guy first. You get this nitro. In this nitro here, when you react it with NaNO2 HCl. You understood Victor Meyer's test fully, or you do not understand it? Or am I doing this just for the sake of doing it now?
No, sir. I understood.
No, if you understood it in school itself, then I don't need to do it now. No?
Yes, sir. I mean, it was okay, sir. Yeah, you don't need to do it. It's fine.
I don't need to do this, is what you're saying.
Yeah. I mean, yeah.
Since I already started, I'll wipe it out anyway.
Okay.
This will generate your NO plus, which will basically go and replace this hydrogen, giving you a compound which looks like this. What is this compound called?
This just now told.
Hmm.
Night.
This is called pseudo-nitrolic acid
Okay.
because this is not an acid.
Yeah, because there's no acidic edge.
Yes. So this is what happens for a secondary. Tertiary, will give you this. This nitro will be formed, but NaNO2 plus HCl will give you no reaction. This is basically the idea here. This is your Victor Mayo's test at the end of the day. You got the colors available in your school there. I'm sure your teacher has given you the colors there, yes?
Yes, sir. Yeah.
So how do you get the colors? You basically end up adding basic medium to the ending. Once you got
Then
the nitrolic acid, you add basic medium to it, you get your color. And the pseudo-nitrolic acid also, when you add a basic medium to it, it gives some other color.
So nitrolic acid is the name of that specific thing, or like that the type of.
This type of system is called nitrolic acid.
Okay, fine. Yeah. Hmm.
Yeah, this type of system is called nitrolic acid.
Yes. Yeah.
Okay, all right. Now, that clears off Victor Mayer's test also. Last up is the really main thing, iodoform reaction. Haloform reaction is something which is a very important reaction, mainly because it is asked enormous number of times in JEE Advanced. Enormous number of times, literally.
Hmm.
It is asked very frequently in JEE Advanced. It is a very standard thing which gets asked. Now, when it comes to haloform reaction, you need to know the mechanism inside out for the overall thing. Did you do the mechanism first?
No, sir.
Looks like your teacher is doing justice this time. So let's start off with what you should know for this chapter and just discuss that. I'm guessing your teacher also did something along those lines.
Yeah, he gave like few points. That's it.
You will be diving very deep into this enough number of times later. So do not worry about that for now. Okay. Okay. So let's say I'm going to be having an alcohol or an aldehyde actually. Any of them will work like this. So I can have an aldehyde of this type, or I can have an alcohol of this type. Okay. If I have something like this, now there are variations also allowed in them. This and this, the CH3 parts over here can be any variation among the following. It can be CH3, it can be CH2X, it can be CHX2, it can be CX3. Any one of these variations it can be. Okay. If it is an alcohol, I absolutely must have a hydrogen on this particular location here, along with the alcohol.
Okay.
Or it can be an aldehyde like this. Yeah.
Yes.
These are my initial starting reactants. These guys when we are reacting them with I2 in the presence of basic medium. Okay, so now this is going to be the, what to say, bare condition which you need, but they will not give you necessarily in these formats every time. And I say I2 in basic medium, they can give it to you in many different ways here. So this I2 here can be something where the I2 is generated during the reaction and then basic medium is present. Or they can give you the combination of whatever is going to be the product obtained over here. When you have I2 in the basic medium here, you're going to be having reaction basically being what? This is going to be dilute basic medium usually. Okay. Sometimes you'll also have concentrated basic medium, but you'll have iodine in basic medium generally. There are many different ways in which this mixture can be given. Instead of giving it as I2 in basic medium, they can give it to you as NaOI. Or they can give it to you as CaOI, or other they can, what to say, how to put, they can actually give it to you directly as calcium hydroxide and I2. That is also feasible.
Okay.
What is the format in which your teacher gave you?
KOH plus I2.
KOH plus I2. So he directly gave you I2 and KOH, I2 plus OH minus only. Okay. There are other ways also in which, yes, sorry?
Nothing, sir.
Yes, you're saying something?
No, I'm saying.
Okay. So there are quite a few other ways in which the same mixture can be given to you. You will find a whole different bunch of them as you are proceeding on. When you are learning more and more of the chapter, you will find that this I2 and basic medium can be given in many different ways. So they will play around with how else to give it in different ways. What is going to be the reaction there? The reaction is going to be a very complicated one. We will discuss that in full mechanism in detail when we have to discuss it. For now, it is not time to discuss. What is going to be the product though? The product is going to be CHI3. Okay. Now, this is going to be the case if it's going to be iodoform reaction. If it is haloform, you'll have X2 and OH minus. Or different ways in which X2 and OH minus can be given, that will be given. And in the case of X2, you will be getting CHX3.
Okay.
Now, one or two key points about this here, about this thing here, CHI3 here, this is obtained as a yellow color precipitate. So haloform is a proper yellow color precipitate. CHX3, not necessarily a precipitate. Iodine, it is a precipitate. Chloroform and all is not a precipitate.
Okay.
Okay. So this is going to be the reaction here. What happens to the leftover other part over there? That becomes a very interesting type of scenario here in this case here. So if you're going to be having the reaction considered here, this part over here is what is going to be becoming the CHX3. This CH3 bit here. And you will end up having this part over here basically becomes the carboxylic acid type of system there. Okay. You understood or not? So if I have say R over here attached, I'll be having this part becoming COH. So I'll give you the product here. I'll show you a little bit more carefully. So if I have say CH3, CH, OH, and then R. Okay. If I react this fellow with KOH and I2, what will I be getting as a product? I will definitely get CHI3 as a precipitate. But along with the CHI3, I will also be getting R, CH, R, COH, sorry, R, COOH. Okay, this fellow will basically end up becoming a carboxylic acid. It will originally become an aldehyde and then it will become a carboxylic acid.
Okay. Fine. Yeah.
Okay. So it will actually become not COH, it will become CO minus.
That's
Basic medium.
okay.
We'll discuss the mechanism when we have to discuss the mechanism.
Okay.
For now, this is enough.
Sir, it's an identification test for aldehydes and alcohols.
Yeah, aldehydes and alcohols.
Okay.
So the alcohol in the reaction here actually becomes the aldehyde in the first step. And then the aldehyde performs the reaction actually.
Okay. Yeah. Yeah.
Okay. So that brings me to a close of whatever I wanted to discuss. What else is left over to talk about? Anything else to discuss for today?
No, sir. That's it.
Any doubts?
No, sir. Nothing else.
How is your preparation coming along? Otherwise,
Yes, sir. It's fine. Physics is kind of shaky for now. Like doing capacitors right now. And then that's it. Yeah.
is it
Kind
coming
of
good?
Not very good, but I'm still working on it. So I still have a few more days. Yeah. Gotta get that fixed.
Okay.
Yeah.
You have a tough journey ahead, Ra.
Yes.
I already told you a long time back itself. It's only work, work, work from here. Plan properly and work. You have any other doubts with respect to chemistry preparation? Any things that you want to discuss?
No, sir. Nothing else.
Then we'll close the session here then today then.
Okay, sir.
Bye bye. Any general doubts? Have you worked on any questions?
Questions? No, sir. Not yet. I've not started questions.
Any information about the ranks from your institute?
Oh, sir. Madhapur Samagya got 13th rank.
13
Yeah.
in
That's all I
Kritli
know.
Madhapur.
Yes. That's all I know, sir.
Very nice.
Yeah. He was not the one who got 300 in mains.
Yeah, he will not be.
Yeah, you told last time.
You understand the reality now, na? The guy who's gotten 300 in mains, what is his rank?
I'm not sure about that.
He'll be like around 1400, 1200, maybe
Uh,
200, maybe 300.
yeah, I'll ask, sir. Yeah. I'll try to
Find
find out.
out. I'm curious.
Yes, sir. Yeah.
Because that is how the reality will be.
Yes, sir.
I'll be very surprised if that kid has gotten under 100. Sincerely. How many under 100s do you guys have for Gila in there this time?
Not sure, sir. All I know
Not
is 30th rank. Yeah.
13th rank is here though.
Yeah.
Nice, nice, nice. In your campus or the Madhapur campus?
Madhapur campus, sir. Our campus, I'm not sure about that yet.
Okay, all right. Okay, bye bye.
Thank you, sir. Yeah.
Nice.
Have a nice day.
Have a nice day.
Bye, sir.
Bye.